A single acting cylinder is controlled by a 3 two-way valve. This is reversed by the two signal transmitters E1 and E2. As the switched position remains unchanged even after deleting a signal, this valve is a memory element. In memory circuits, it is possible for signals E1 and E2 to be transmitted simultaneously. The memory can no longer switch over. The reversing forces for the memory cancel each other out. In a control, the following occurs. Signal transmitter 1, 2 switches over 1, 1. 1, 0 travels out. The cylinder operates 2, 2. 2, 2 controls 2, 1 and 2, 0 travels out. Memory 2, 1 now carries simultaneously the signals from 2, 2 and 2, 3. We will follow this sequence of operations on the circuit diagram. Cylinder 1, 0 travels out. We designate the outward motion by plus and that of 2, 0 also by plus. The return motion is designated by minus. This third step marks the situation in the circuit diagram in which signals 2, 2 and 2, 3 oppose each other. This can be avoided by means of a cascade or shift register control. Functioning of a cascade control. Here, the control pressures of 2, 2 and 2, 3 are of equal magnitude. Signal 2, 3 cannot be effective until the signal from 2, 2 is 0. To make this signal 0, the signal transmitters are supplied through different control lines. These supply lines are opened or closed as required. To be able to recognize the critical situation, we label the cylinders with A and B, and allocate plus and minus signs to them. When the signs for one cylinder reverse, we have the situation in which the signals oppose each other. Switching over of the control circuits is effected by means of a memory, the two outputs of which supply air alternately to control circuit 1 or control circuit 2. In this example, we have frequent change of sign. A plus, B plus, B minus, C plus, C minus, A minus, A plus, A minus. Control circuit switchover must be effected between B plus and B minus, C plus and C minus, A minus and A plus and A minus, as well as between A minus and the start A plus. Thus, we need 1, 2, 3, 4, 5 control circuits. These are switched via 4 memories. The number of memories equals the number of control circuits minus 1 because the upper memory acts upon 2 control circuits. Switching over of the various control circuits takes place as follows. A signal, E1, switches over the lowest memory. Control circuit 1 is supplied with air. Control circuit 5 exhausts. Signal E2 switches the top memory. Control circuit 1 is exhausted. Control circuit 2 is supplied with air. Signal E3 switches over the next memory. Control circuit 3 is pressurized and the top memory is reset via control circuit 3. Control circuit 2 is depressurized. Signal E4 switches over the next memory. Control circuit 4 is supplied with air. And control circuit 3 is exhausted. Signal E5 switches the lowest memory. Control circuit 5 is supplied with compressed air, and control circuit 4 is exhausted. We have again reached the starting position. This method of control circuit switching is called the cascade method. If we switch over at each step, rather than when the sign changes, we have a shift register. Functioning of a shift register. Shift register switching is to be performed on the control circuit switching example with which we are familiar. We now have not only 2, but 1, 2, 3, 4 control circuits. Signal overlap is avoided under all circumstances by the shift register, even if the control is modified at some later time. We make use of logic symbols in the control circuit representation. This memory has the input E1, which switches on output A, and an input E2, which deletes the output signal A. In a shift register, one requires as many memories as cycles. The memory outputs are connected to the control inputs of the 4 two-way valves in the order of execution. If the first signal transmitter, E1, is operated, we obtain the output A1 of the memory. This operates the control valve 1-1, and the cylinder 1-0 travels out. Signal A1 is input simultaneously to an AND function in front of the next memory. When the cylinder operates signal transmitter E3, we now obtain, via the AND function, switchover of the memory and hence output A2. AND function in front of the memory ensures that the signal transmitter is effective only if the preparatory signal from the preceding memory exists. This ensures correct sequencing. Output A2 as input signal E2 on the first memory causes A1 to be deleted. At the same time, it provides the preparation signal for the next memory. Control valve 2-1 is switched over. Cylinder 2-0 travels out. On operating signal transmitter E5, the third memory is switched over. We obtain output A3, which, via input E4, deletes the second memory. The AND element of the last memory is prepared, and valve 2-1 switched over. On operating signal transmitter E7, the last memory switches to A4, deletes via E6 the preceding memory, and provides a signal to valve 1-1. Cylinder 1-0 moves back and operates signal transmitter E8, which deletes the final memory. The system is again in its starting condition. Using this design, any number of steps may be executed with one shift register. Let us summarize. By entering the cylinder designation with plus and minus sign in the sequence diagram, we obtain the switchover points for the control line. Switching to the various control circuits is performed by means of memory valves. This switching sequence is called a cascade. If we switch over at the end of each sequence, we have a shift register control. Neither of these controls are intended for frequent changes of program, and for this reason they are termed fixed programs.